The following geometric pattern suggests a sequence of numbers. How many dots will be needed to construct the 100th term of the pattern? How many dots will be needed to construct the nth term of the pattern? So the first term needs 1 dot, the second term needs 5 dots, the third term needs 11 dots, and the fourth term needs 19 dots. So we need to find out how many dots I'll need to construct A subscript 100 and how many dots I'll need to construct A subscript 9. So that's the 100th term and the nth term. Let's first try to answer the first part of the question. We need to find out how many dots are needed for the 100th term. Take a look at this picture. This is a picture that we had in our question. And the first term needs 1 dot, the second term needs 5 dots, the third term needs 11 dots, the fourth term needs 19 dots. These numbers 1, 5, 11, and 19 they don't form a geometric sequence, they don't form an arithmetic sequence. So how do we solve a problem like this? We have to look at the picture. That's why this kind of a pattern is called a geometric or pictorial. By the way, the question says it's a geometric pattern. It doesn't say it's a geometric sequence, so don't confuse the two. So let's see what we can do. Now I don't see anything right away when I look at the numbers, so I have to analyze the picture. So what we have here is we have the same pattern, but I added a blue dot to each term. Why did I do that? By adding one blue dot to each term, I think I can make sense of the array slightly better. And I'm only interested in the pink dots. I'm not interested in the blue dot. So what I see here is the first term is 1 row of 2 dots. The second term is 2 rows of 3 dots. The third term is 3 rows of 4 dots. The fourth term is 4 rows of 5 dots. So the 100th term should be 100 rows of 101 dots. But I have to take care of one thing. I have to subtract 1 because I shouldn't be counting the blue dots. So that's really what we are trying to do here. So the 100th term, according to the pattern, should have an array 100 times 101 array, and that includes the blue dot. Take a look at it. This one is 1 by 2. Let's look at that pattern. This one, including the blue dot, and we are going to adjust that. It's 1 by 2. This one is 2 by 3. Just the array. This one is 3 by 4, and this one is 4 by 5. 4 by 5. So the 100th one should be 100 times 101. But these arrays include the blue dot, which you have to subtract, -1, and your answer should be 10,099. That's the answer to part A. So erase everything. Now the next part of our question is how many dots will be needed for the nth term. So using the exact same argument, the nth term should be n rows of n plus 1 dots, but then I have to subtract 1 because n times n plus 1 includes the blue dot. This 1 refers to the blue dot, and all I did here is some algebra. N times n plus 1 is n squared plus n minus 1. So you really want to understand this. Let's write this down once again. This is 1 times 2. This is 2 times 3. This is 3 times 4. And this is 4 times 5. And that includes the blue dot, and that's why I subtracted. So the nth term should be, if you had to write A subscript n here, let's write it like this, A subscript n. That should be here, including the blue dot. If you want to continue the pattern, should be n times n plus 1. And I am interested in the blue dots because that's what the question is about, and I added my I'm interested in the pink dots, not just a blue dot, so I subtract 1. So my final answer is this for the second part, for the number of dots needed for the nth term, and the number of dots needed for the 100th term is this. So these are my answers.